Okay. We are still going to stick with probability today. We're going to go a little bit further with that. We're not going to spend the whole unit on that, but I do want to throw in a couple more scenarios. But first, let me answer the ones from yesterday. That way you can check your work. Make sure you're doing the basic ones correctly. If I can get this to work. All right. What was the probability of that coming out right? No, you had to roll a 2. So rolling a 2, you had a 1 out of 6 chance. Okay, remember you put favorable over possible. So 1 divided by 6 comes out to that 0.16, and it keeps repeating. Move the decimal twice and round to the nearest percent. So 17%. That goes up to 17 because that's higher than 5. 5 or higher makes this go up to 7. So that's 17% for rolling a 2. Okay, rolling an odd number. So there's 3 odd numbers. So you have 3 out of 6. That divides into 50%. Okay. Then I had you rolling a 5 or a 6. Remember we talked about and or. You can't roll a 5 and a 6 at the same time. That's impossible. But you can roll a 5 or a 6, which means you got 2 favorable outcomes out of 6. Okay, so we're going to do 2 divided by 6, which should come out as 0.333, but we'll make sure. We'll do 2 divided by 6, 0.3333, so that's 33%. Okay, it means you have 1/3 of a chance. And those that remember fractions, this can reduce to 1/3, so that's why that is. Then I had you doing the cards, okay, the deck of cards, and your chance of drawing a 4 was 4 out of 52, okay, which as a percent was, if you round to it comes out to 0.076 and so on. Move it twice, round to the nearest percent. You have an 8% chance. Okay, drawing a heart, you had a 13 out of 52. Okay, there's 13 of each suit. So there's 13 hearts. You have 13 hearts, and that is 1/4, which is 25%. Comes out to 0.25 when you put in your calculator. 13 divided by 52, so you have a 25%. And then I put one on there, drawing a 7 of diamonds. I wanted to put kind of a new one up there. 7 of diamonds. There's only 1 7 of diamonds in a deck. So there's 4 7s, but there's only 1 7 of diamonds. So you have a 1 out of 52 chance of drawing that card, the smallest possible of drawing a card. And so that comes out 0.0192. When you move the decimal twice, you get 1.9, so you have about a 2% chance of drawing that single card out of a deck. Okay, it's the smallest chance of, unless it's 0, unless you're trying to draw like a card that doesn't even exist, like a 14. You can't draw that out of the deck, so that's a 0%. But drawing that 7 of diamonds, you have a 2% chance of drawing that one card. Okay, and card player, game players, they have to always be doing these percentages to figure out, well, what's my chances of drawing the card that I need, or if there's a couple cards that would work, then the percentages go up a little bit, and so on. Okay, and I'm not saying, like I said, we're not going to do this everyday life, but you can apply these things to everyday life. Like, what's my chances of this happening? Well, how many chances are favorable out of how many possibilities? And that will tell you how to do the probability. Okay, let me keep going with this a little bit, and we're going to just add some more to it. So going back to the rolling of a dice, okay, let's say I wanted to roll a 2. I had a 1 out of 6 chance, okay, of rolling that 2. And that, like you said, we did that. I think it came out to 17% chance of rolling that 2. But let's say I pick that dice up again and say, okay, now I want to roll a different number. And so we're talking about kind of doing consecutive probabilities. So let's say you're playing a game that you have to roll a 2 first, and you roll that 2 and you win, and you're like, okay, now I have to, after rolling that 2 correctly, I have to roll another number. And so we got to look and say, is it the same possibility as just doing it one thing at a time, or does it become harder because you're trying to do two things in a row? And the answer, hopefully you're realizing just by thinking about it, that it would be harder to do things in a row. Like if I say to roll a 2 and you just got to make one roll and you roll it, you got that 1 out of 6, you had a 17% chance. But we know to do things in order then to say, okay, you rolled a 2, that was hard enough. Now you've got to, right after rolling that 2, you have to roll a 5 or something. And we know that that becomes harder because you could have got the first one right, and now it's harder to then get the second one right as well. It's kind of like those games where you have to pick like 8 numbers in a row correctly. And I'm not talking about gambling or anything. Just doing things in a row, like having to do something correctly and then turn around and do it, something else correctly as well. It becomes harder each time, each consecutive. So your chances go way, way down. So this example of rolling a 2 and then a 5, and I use that word "and" because now we're talking about 2 different rolls. This is not rolling a 2 and 5 at the same time. This is rolling a 2, picking the dice back up, and then on the next consecutive roll, rolling a 5. Well, how do we do that? Is it just 1 out of 6 and then the same percentage on the second one? Well, it's an 18% chance both times, or 17% chance both times? No, because you're trying to do them in order, it becomes harder each consecutive roll. And how you find that out then is it is 1 out of 6 on the first roll, it is 1 out of 6 on the second roll, but because you're trying to do them in order, you've got to multiply those fractions. And don't freak out, because if we go back to math lab and remember, multiplying fractions was actually pretty simple. You don't have to worry about least common denominator, even though these do have a least common denominator. You don't have to do any of that. All you have to do is just multiply the tops. So 1 times 1, not add them, multiply them. And then 6 times 6. So it's 1 over 36. So our percentages of rolling a 2, picking up the dice, and then rolling a 5 are very, very small. In fact, we'll put that in 1 divided by 36. And it's 0.027, which is about a 3% chance. Okay? As you can see, it was about a 17% chance to roll the 2. And let's say that was all you need to do, and you started the game over, and you're like, okay, game's over. Now you're just going to start a new game, and, it doesn't matter what you roll, and then you pick any number roll. Each time is a 17. But if you're playing a game that you got to roll a 2, and then on your very next roll a 5, that's how hard it becomes, okay? It goes from 17% chance to down to 3% to be able to do that. And each time you have to consecutively roll the right number, it becomes harder and harder and harder. Yahtzee is a game that I think of. You're playing the game Yahtzee, and you may have to play a game where you have to roll this, and then the very next roll get this, and to make it work, and that's why it becomes very, very hard to do that, because the percentages go down each time. Let's translate this to the deck of cards, okay, and see how that you can apply this to anything then, but it becomes harder and harder. Let's say I want to draw a 5 from the deck, okay, so I draw a 5. That is a 4 out of 52 chance, because there's 52 cards, there's 4 5s, and so I have a 4 out of 52. And here's an important piece, because the dice is the same 6 dice, 6-sided dice every time you pick it up. The cards, until I put that card back, now I only have 51 in the deck, right? If I draw that 5 out, then all I have is 51. Now, if I put it back in, if I put that 5 back in, I'm back to 52 cards. So keep that in mind, whether I say you put the card back in or not, because here in a second we'll do one where I don't put the card back in. So let's say I draw out a 5, okay, I had a 4 out of 52. I put that 5 back in the deck. Now there's 52 cards still back in there. And I say, but now on the very next draw, I want to draw a king. So that is also a 4 out of 52, because there's 4 kings in the deck. And I put the card back in, so there's 52 cards. And I've got to multiply them. If I want to do them consecutively, I've got to multiply them. So we're going to take 4 times 4, which is 16. and then 52 times 52, which is going to be a huge number. It's 2,704. Okay. So now we have 16 over 2,704. So to find that percentage, I have to do 16 divided by 2,704. And it comes out to 0.00591, so on. If I move the decimal twice, I actually have 0.59%. That's not 60%. That's less than 1%. And so let's say I round it to the nearest tenth of a percent. I have 0.6%. That is less than 1% of doing that. Okay, so it's very, very hard. It's less than 1% to draw a card, a 5, like that, put it back, and then draw a king. Okay? Let's do a scenario where I draw a card like this and then don't put it back in. It just changes one little thing, but let's do a scenario of that. Let's say I draw a, well, let's do it like this. Let's say I draw a heart. And this way we'll get a little bit bigger percentage because, you know, you've got 13 hearts. So let's say I need to draw a heart. Oh, no, I don't want to do that yet. Sorry, re-scratch, edit, delete. Let's stick with this. Let's say I want to draw a 6. So I have a 4 out of 52. Okay, that's the same as always, drawing a 6, 4 out of 52. And let's say I set that 6 down. I don't put it back in the deck. And now I want to draw a queen. Okay, well, there's still 4 queens. But now, since I set that 6 aside and didn't put it back in the deck, there's not 52 cards anymore. There's only 51. Okay? There's only 51 cards. And so, this is not going to be a drastic change from the one before because all that changed was down here by 1. But let's check it out. So we still have 16. And then down here, instead of 2,704, we've got 52 times 51. Is 2,652. It went down a little bit. And then we're going to take 16 and divide it by 2,652. So now it's 0.00603. And so we move it twice. It's still 0.6, but we didn't have to round this time. It was just a little bit higher percentage because you had one less card to be wrong on. Because if I took the 6 out, that's one less possibility in the deck that's favorable for me because now I'm trying to get a queen on the second one, so there's one less card to be wrong on. So that's why my percentage went up just a little bit, not much, but you know, just a little bit on that. Okay, so but hopefully you're seeing the pattern of don't necessarily get caught up in like, oh my goodness, it keeps changing. Just realize what you're changing each time. Really think about how many favorable outcomes over how many possible, and that will always help you put in the right numbers at that point. Let's do one of drawing a, now let's do the heart one I was talking about. Let's say drawing a heart. Okay, so I had a 13 out of 52. Okay, there's 13 cards in there. And let's say then I wanted to draw a spade on the second one, and I didn't put this card back in. Okay, so now there's 13 spades, but there's 51. That's 51 cards in the deck. And what's nice is that heart is no longer in there. That's one that would have hurt me. You know, it's not a favorable one. So let's do this one. This one's going to be bigger. So 13 times 13 should be 169, yeah. And then we had, I think it was 2,652, if I remember. Yeah. Okay, so we're going to do 169 divided by 2,652. So this one comes out to 0.0637. Move the decimal twice, you have a 6%. That's not 0.6, that's 6%. That's a lot better than 0.6. Because you know, there's more favorable when you're doing hearts and spades than number and number. Let's do this one. This is the last one we'll do with the cards, and then I'll introduce one that kind of practices this, and this is what your assignment's going to be on. But let's do one that's a little tricky. Let's say you had to draw let's say we had to draw a 7 of diamonds, like your homework I think was, a 7 of diamonds. And so you had a 1 out of 52. Okay, you drew that 7 of diamonds, and let's say you set that card down, you didn't put it back in the deck, okay, and so now we know there's only 51 cards in the deck. So do that each time, figure out, well, what's my possible and what's my favorable? Well, the first one, there was 52 cards, I had a fresh deck, and I wanted to draw that 7 of diamonds. There's only one of them. But if I put that card aside and don't put it back in, now my deck only has 51 possible outcomes. And let's say on the second one, you want to draw a diamond. Okay? Now, this is where it gets tricky. There's 13 diamonds in the deck, so we think, oh, well then to draw a diamond is 13. But what card did you set aside? You set the 7 of diamonds. It's no longer in that deck. It's no longer one of your choices. Meaning I can't draw that 7 of diamonds because it's sitting out of the deck. So not only did this go down because one less card, but there's one less diamond in the deck. So now there's only 12 diamonds in the deck. Okay? So you just got to keep track of your favorable and your possible, and it will help you. Now we multiply these, so we get that 12 over 2,652. And let's divide that. Oh, why I keep shutting my calculator off. That comes to 0.00452 and so on. Move the decimal twice. We get 0.45, so we'll round that up to 0.5%, so 0.5%. You say, well, why is that so low? Because this card was really hard. You know, that first draw was really hard. But the second one became easier, but first draw was really, really hard. So 0.5% rounded to the nearest tenth on that, okay? Now, what we're gonna keep practicing with this is I'm gonna introduce a new thing, and that's drawing marbles from a bag. And I know these are kind of silly in the way if you don't do them every day, but you can take this and apply it to everyday things if you need to. But let's say we have 4 yellow marbles in a bag, and I think I put 6 green, 12 blue, and 8 red. So I put these in a bag, okay? And I want to practice, you know, drawing a marble out and what's my chances, and then what's my chances of drawing one after another, and that kind of thing. Okay, so first off, let's just do a simple one. Let's say I want to know the chances of drawing a red, okay, drawing a red marble out of the bag. Well, first off, how many marbles are in the bag? What's my possible outcomes? Well, you have to add them up. 4 plus 6 is 10, 22, 30. Okay, so there's 30 marbles in the bag, okay, and I want to draw a red. Well, there's 8 reds, so there's 8 favorable ones in there for me to win. So I have an 8 out of 30, so let's just do that. 8 divided by 30. I have rounded, it comes out to 0.266, it keeps repeating, so we're going to round to the nearest percent on this one, 27%, okay. In fact, let's go ahead, I know those are kind of commenting they want to make sure they know which one they're rounding to, because these other ones get really small. Let's go ahead and say we're going to round to the nearest tenth. That way we cover all the bases. So this one again came to 0.266, keeps repeating. Okay, we're going to move it twice. So it's 26.66%. That makes that go up to 7, so rounded to the nearest tenth is 26.7%. Okay? So we'll just, from this point on the marbles, we'll round to the nearest 10. So you have almost a little over a quarter of a chance of drawing a red marble from that bag, okay? There's a little bit more of a chance than a quarter of a chance. That one's just a simple draw a red one out. Let's say I want to do one where I draw a green one, so 6 out of 30. And let's say I put it back in the bag, Okay, so I drew the green one, put it back in the bag, and so there's still 30 marbles. And I'm going to end up multiplying these, but let's say on the next draw I want to draw a blue. So I want to draw a green and then a blue, okay? And I put it back in the bag. Okay, so that's green, that's blue, and the key point to keep this 30 was I put the green one back in the bag. Now I just need to multiply the bottoms, so that's going to be 900, and the top's going to be 72. So let's do 72 divided by 900, and it's 0.08. Move the decimal twice, okay, and that's 8%. That is rounded to the nearest tenth because it came out even, okay, so there's nothing to round to. It could be 8.0, but 8% chance of drawing a green, putting it back in, and then drawing a blue. Let's do another one of those. Let's say I draw a blue, 12 out of 30, and I put it back in and I want to draw a yellow. So 4 out of 30. Okay, so this is going to be 48 over 900. And this one comes out to 0.053333 and keeps repeating. Move it twice, and then round to the nearest tenth, 5.3%. Okay, so 5.3, less than the other one, because there's way less yellow ones in the back. Okay, not way less, but just a few. So that makes it less than the 8% one we just did. Okay, let's do one where we don't put the marble back in the bag. Okay, so let's say I want to draw a green. And let's say I don't put that green back in the bag. I set it off to the side. So now there's only 29 marbles in my bag, 29 possibilities, and I want to draw red. Okay, there's still 8 red in there. So now I do 30 times 29, which should be 870, yeah. And 48, okay? That's 8 times 6. So now we do 48 divided by 870 is yeah. 48 divided by 870, 0.05517. Move the decimal twice. It becomes a 5.5%, rounded to the nearest tip. So whether you put that back in the bag or not matters, okay? One last thing to look at is, let's say you pick consecutive colors. So let's do I want to draw let's draw a red one. And let's say I put it back in the bag. Okay, so there's still 30. And I want to draw a red one again, which, you know, that a game could be that way. Draw a red one, you put it back, and now you need to draw another red one. Well, there's still 8 red in the bag. There's still 30 because you put it back, and that red one's still in there because you put it back. And so now you get 64 over 900. So we're going to take 64 divided by 900, and it comes to 0.07111. Move it twice, you got a 7.1% chance of drawing a red, putting it back, and then drawing another red. Let's do the same problem, drawing a red, but let's not put it back in the bag. So now there's only 29, and you want to draw another red one. Well, is this one 8 again? No, because the red one you set off to the side. So now there's only 7 red in the bag. So you drew the 8, the first part of the bag, you had 30 in there, that 8 one, you pulled out a red one, you set it off. Now there's only 29 marbles in the bag, and you want to draw another red. Well, there's only 7 red because you set that 8th one, you set that other one off, okay? So now you have 56 over 870, okay? And that comes to 0.0643. So you move it twice, it's a 6.4% rounded to the nearest tenth. It went down a little bit. See, the other was 7.1. It went down because you took one of those red ones out. Okay, even though there's less possibilities, that red one really affects it by not sticking it back in. Okay, so that gives you a different look at it, all the different possibilities that you can look at. Go back and watch some of them. Just be real careful with your favorable and not favorable and possible, and keep track of that. So your assignment, I'm just going to give you 5 quick ones real quick. Okay, so on a deck of cards, or I'm sorry, same marbles. Okay, so same marbles, 4 yellow, 6 green, 12 blue, and 8 red. Okay, so same bag of marbles. I want you to find out what it is to draw a green, the probability of drawing a green, and put that round to the nearest tenth on all these. Okay, so drawing a green, then drawing a blue, putting it back, and then drawing a yellow. Okay. Red, not putting it back. And then yellow. A blue, putting it back, and then another blue. And the last one, a yellow, not putting it back, and then yellow. All right, so try with those, see what you come up with, and we'll check them tomorrow. Thanks, guys.